The USGS letters and slogan "Science for a Changing World" appear in white in a flipping motion, then fade to black.
Hello, and welcome to the U.S. Geological Survey Hydrography Community Call. I am Karen Adkins with the National Geospatial Program User Engagement Office. The topic today is delivering and using 3D hydrography program data by Sylvia Terziati, the National Geospatial Program Hydrography Science and Applications Lead. I just wanted to make a brief announcement about upcoming hydrography community calls. Our next call we're planning for January 28, 2025. And this will be a change in how we are presenting the hydrography community calls. In the past, we've had them generally monthly with some combined meetings and some skipped meetings. We are planning to hold the USGS hydrography community call quarterly in 2025 with interim meetings as needed. And the agenda will include announcements such as new information, data releases, and other important announcements that the National Geospatial Program needs to make. There will also be updates on products, services, public applications, the website, and any other news that we need to share. We will also have periodic special topics, some from 3DHP research, some from 3DHP operations, and other hydrography topics as they become available. So look for these changes moving forward. And I am going to stop sharing and let Sylvia Terziati take over and share her screen.
Thank you, Karen. I'm going to be presenting on 3DHP, a little bit more in depth on the data model. Wanted to just give people a little bit more of a deep dive into what 3DHP is going to look like. Although there's a lot more to go through as well. So please go ahead and ask questions as you have them. But these are the areas I'm going to be covering. So we're going to be talking about what is actually the data sources, the input to the 3DHP data model. We'll talk about once it's ingested in the data model, what those core components are. And then we'll talk about ways that we plan on delivering 3DHP data to the public. So first we'll talk a bit about the design and the input. So I know you've heard a lot about 3DHP on these calls. So I'm just going to reiterate a few things that were important to us as we were looking at the data model and determining how to restructure, hydrography as a data set and how we were going to be maintaining it. And some things, became evident fairly quickly that we wanted to have something that was really that second bullet there, implemented as a more simplified data model, because the NHD and NHD plus was fairly complex, difficult to maintain. To simplify that data model. We wanted to make sure it was consistent in the coding and the density, because that was another problem that we had with some of the historic data sets where there was a difference in the density between collection areas. So we're trying to standardize that. We wanted to make sure it supported hydrologic applications. So it's really the framework that hydrologic applications can be built off of. And we also recognize that we have a very important kind of sister program, the 3DEP. We wanted to have that integration with the elevation data. So we wanted those 3D capabilities built into the 3DHP as well. And we also recognize the open source and community developed data models that were out there, we wanted to be compliant with what was being developed in OGC world. So we looked at the high features model, and we are building off of that. That's more of a conceptual model. So we're taking that and making it a more a model that can be used and implemented. And we're also from the high features adopting the way that rivers are being identified so that we have unique identifiers to replace our reach codes that were feature-based. We are now adopting a main stem identifier system so we can identify entire streams instead of little pieces that would need to be maintained and can get quickly out of hand. So first we'll talk about the input data. So how do we get data into 3D-HP? So the first thing you'll probably notice when you look at 3D-HP today is that it looks a lot like the NHD, because most of the data in there, and really at this point, all but one HUC-8 is the line work from the NHD high-res data set. So one of the things that people did not want to have was just a piecemeal type of data set. They wanted to make sure that if we're converting and supporting a new data set, that we had a national network that could be navigated and addressed to. So we went ahead and used the NHD high-res, which is the best available hydrography data that we had, and imported that into 3D-HP. And with that, we imported 95% of the features, but only 10% of the feature types. In other words, most of the NHD is a core group of feature types, and those are the ones that we imported into 3D-HP. We dropped some that are more cartographic or are very specific to certain applications, like you always hear the swimming pools and the rocks and waterfalls, those examples that we don't have in 3D-HP. But it does create, 90 or does include 95% of those NHD features. The two primary things that we conflated from NHD to 3D-HP were the GNIS name and the reach code start and end. So every feature that is ingested from NHD has the name and reach code start and end, so that you can tie it back to NHD data if you have things that were stored by reach code. We also have a crosswalk within the documentation that shows how those NHD features were assigned to 3D-HP feature types. And out of those 107 feature types that NHD had, we have about 22 within 3D-HP that all of them are crosswalked to. So that's the NHD. So that's really the core backbone of 3D-HP, the NHD-source data. But the plan is, of course, to update that data with elevation-derived hydrography. And we have been working on these specifications to define what EDH or elevation-derived hydrography needs to look like in order to be used within 3D-HP. And so first published in 2020, each year we've come out with one or two new revisions to the specification, because as people are using it and trying to build data set to the spec, we find that, things aren't explained quite as well as we'd like, or things just don't work, which when we first wrote this, we didn't know how things were going to really all be fit together. So we've had to do a few changes. And actually, you'll see at the end of the month, a new specification that's coming out, which will have a combination. It's going to take all of the guideline documents that we've been developing and the two specifications for EDH and combine them into one specification. So I'm sure when that's out, we'll have an announcement. You'll all be able to, download that and take a look at it. So the EDH specifications are really designed to make sure that our elevation and our hydrography are well integrated, both horizontally and vertically. So every vertex on a stream network has the z-value. The z-value is at or below the elevation surface, and it's downstream monotonic. And all of our streams are also horizontally placed so that they're within a channel on the surface. So those are the primary objectives really of the specifications and the requirements that we've built into that specification. So here's some examples just of the original NHD in a small area and the improvements in density in that same area. And you can see that the data that's been captured is quite a bit denser, but it also fits more neatly into the channelized features. So we have both the horizontal and vertical placement of those features. The other aspect of the 3D-HP data model is, well, the EDH schema, is that it has features that allow that integration with the surface. And most of you have heard about the breaching features, which for most people means culverts. So we do include the stream segments within a channel that are identified particularly specifically for breaching. So you might have a stretch of river that has, 3 or 4 breaching elements integrated within that main stem or within that flow path. And those are used to hydroenforce the surface so that when we're creating catchments and other elevation derivatives, we make sure that the elevation surface matches our hydrography. And this is just a very simple example of z-values on the vertices of the hydrography and how there is a downstream monotonic direction and value assigned to each one of the vertices. So you always have at or below the elevation above or upstream of the current vertex, so it's always flowing downstream. So once we have that elevation-derived hydrography, how does it get into the 3D-HP data model? We'll talk a little bit about that. So how it's going to be attributed and conflated to 3D-HP. So first, just a quick list of the types of features that we have in 3D-HP. And you can see that there isn't a whole lot. As, when you're used to looking at that NHD table of attributes where we have hundreds, it's definitely a much smaller list of the feature types that we have. We're really trying to keep it very simple and able to be defined as features that can be derived from the elevation surface. So we have things like, rivers and canals and drainage ways, surface connectors, water body connectors. These are all things that we can define from characteristics of the elevation surface and the way that they flow over the surface. Water bodies are also very simple, or not simplified so much as just a very small subset of these types. We don't try to assign attribution so much as just define whether or not it's a polygon versus a single line feature. So we have, polygons that can be rivers and canals and lakes, and an ocean or Great Lake. And those are really the only types of water bodies that we're collecting right now. Hydrolocations are kind of an interesting feature type or class. They are made up of both hydrologic features, so springs and sinks, but also define the way that the network is constructed and the way catchments are constructed. So we have things like headwater points and catchment outlets and water body outlets, and ways that we can define how features are connected to each other and how catchments should be created. So those are kind of a dual purpose points layer. The two that are really collected as hydrologic features are springs and sinks, and all the rest are generated as a way that we can use that network and define things within that network. And then we have catchments, which are the overland flow to a feature or to a confluence to confluence within the network. And we'll be using that to define that overland flow to our stream network, and we'll also be able to tie attributes to catchments in the future. And then drainage area is another new component of 3D-HP. For those of you that use WBD, this will be a way that we will be we'll be aggregating those catchments to nest within a roughly 12-digit HUC outlet or boundary. So it's similar to the WBD in size and definition of features of those 12-digit HUCs, but it will be made up of catchments, so that a catchment will always be nested within a drainage area, and those can be aggregated in different ways. And then the other really important part of our network now is the main stem identifier, and that's used to identify a feature in the network. So main stem IDs are part of the high features data model. It's also been they've been assigned to NHD plus medium res and now NHD plus high res features. So what we're attempting to do is to stay consistent with that way of identifying features. We'll be able to tie into those existing data sets, and so that there will be a way that you can crosswalk between our 3D-HP to NHD plus high res to NHD plus medium res, and that main stem ID will always be consistent between them. The important thing about a main stem as well is that it is an entire feature. So for instance, here the Missouri River is going to have one main stem ID. You'll have, locations along the Missouri River that you can define as a location tied to that main stem ID, but that main stem ID is going to identify an entire river or an entire flow path. So the IDs, we do have individual feature IDs, but we also, as well as the main stem ID. So here you have an example of one main stem ID that identifies an entire river, the Platte River, but you also have a main or an ID 3D-HP, which identifies individual segments. So we have two ways that we can identify a feature. The other important table that's included with 3D-HP data model, and it's actually tied to the flow lines, is the flow line or the flow network derivatives table. And that, if you're familiar with NHD plus, does have a lot of the same types of information associated with a stream, but it's really the way that we can support network navigation and flow analysis without having to do that on the geometry itself. So the table has all of the information within it, the flow table, so you'll be able to see what's upstream and downstream and do very, very fast queries of the network. The other aspect to the data model that we're planning to derive and deliver are elevation derivatives. Primarily, the hydro-enforced elevation data set is going to be created by integrating the stream network and the elevation source data so that breaches are part of the elevation surface and the Z values of the stream network are integrated into the surface so that all of the vertices or all of the cells that make up that stream network represent the same values, and they are the slope is maintained within the raster along that stream raster network path. And then as part of hydro enforcing and hydro conditioning, we then create the catchments. We start with catchments around every flow line, but then we do aggregate to our hydro locations. The hydro locations that are most common are catchment to catchment, or sorry, confluence to confluence, or headwater to confluence. So we do a little bit different from NHD plus. We do now have a headwater catchment as well as catchments that flow to streams between confluences. So how are we going to be delivering the data? We talked a little bit already about the main stem ID and how that's tied to other things, but we'll also be, well, we currently have a web service, which is soon to be updated to a web feature service, or a way that we can visualize and query the data and download the data directly from the web application. And we'll be also serving that with an updated symbology, so it's a little bit easier to turn layers on and off and see them within the web service. We'll also have this link through the Internet of Water, the GeoConnect site. We've been working with the Internet of Water to make sure that our data is compatible with what needs to be present in our main stem IDs so that they can be linked up with the existing data, and so that we have that consistent labeling or consistent main stem ID that doesn't get removed or changed in any way. We have reference ones that go direct, that are exactly the same as the ones that are already within GeoConnects, and we're developing a lot more that we hope to integrate into the GeoConnect system. So an example of how you can right now go directly from our main stem ID to GeoConnects and find right now any stream gauge, USGS stream gauge that's associated with a main stem is through our web service. You can click on our main stem ID, which is a URL, and it will bring you directly to the GeoConnects page. And that GeoConnects page will display the entire stream network if it's a reference network. And it and as we populate associated data sets, you'll be able to bring up other data sets that can be displayed on them as well. Right now, the thing that we do have within GeoConnex, or that GeoConnex is hosting, are the gauges. So within when you are returned to this GeoConnex page, you'll see a list of all the stream gauges associated with the river that you've identified, and then you can go directly to information about that stream. And we would love to be able to incorporate many more types of information for different types of applications, either through GeoConnex or through a similar interface, so that you can choose the type of information you want to see, sort of the way Google Maps has restaurants or hotels or gas stations. If you're interested in, stream gauges, you can look at those. If you're interested in, fish or public access sites, you can look at those, that kind of thing. So, but currently we are looking right now, just the stream gauges are available. So, and then finally, the other way that we'll be able to look at this data is by downloading an annual release of the data that will have a digital object identifier associated with it, so that each year that snapshots or delivery of that data set can be referenced, since we plan on updating it throughout the year. If you're doing research or have a paper that you're publishing, you'll want to be able to reference the year and the state that the data set was in when you were doing your analysis. So we will have those annual snapshots that you'll be able to refer back to and do your analysis with. So we do have a number of pages online, and thank you, Karen. She's been filling in, I think, a lot of these links in the chat. So we have the specification site, we have the crosswalks, we have a number of other, about 3DHP pages that you can explore to find out more about the product and the tables. I did want to just do a quick overview of the things we'll be concentrating on in the near term. We have a long list of enhancements already that we'd like to make to 3DHP, but these are the things that are being prioritized. Some are almost complete already, but others are a little bit more research oriented, or things that we're still in progress of defining the best way to do them. But I'll just go through this list real quick. One of the things that's been requested is that the name river be renamed as something. And so we are going to be renaming the description of our feature type that currently is identified as a river as a channel line, because that's really how we're defining those features. We're defining them as as something that you can see on the surface within a channelized part of the elevation surface. So we don't currently have a way of telling you whether or not there's water there, and river definitely has the implication that there is water in that channel. But to remove that implication, we're going to be renaming those as channel lines. We're also working on an international boundary guideline so that we can have continuity between all of the North American areas. We're going to be dropping playa as a feature type within EDH because we didn't have it in 3D-HP, so we won't be collecting that anymore. And we're going to be looking at ways that you can identify closed basins without that playa feature type within 3D-HP. We'll be adding, this is a very popular one, probability of flow table, so that I know people miss the perennial, intermittent, ephemeral classifications. We're not going to be creating those anymore, but we do plan on distributing a way for features to be defined as the number of days of flow associated with a feature. So from 0 to 365, and they'll also have confidence intervals associated with those values. So you can see how confident we would be to say that there's, 50 days of flow or 300 days of flow. We're going to further align EDH and 3D-HP so that we're collecting things that are actually going to be stored in 3D-HP or used for validation. And we're going to kind of just tidy up the annual stage product release and make sure that that's easily accessible for folks to be able to use and find. And then the raster integration, we're another topic that someday we might want to talk about is the 1 meter seamless, which is being developed on our elevation side, which is going to become our source for the EDH derivation. Right now, data providers are responsible for creating that DEM, and USGS is going to be standardizing that process and creating a product that can be used directly for that input into the EDH process. And then we also have to figure out the best way to deliver our hydro-enforced DEMs. And that's all I had.
Sylvia, thank you very much for the excellent presentation, and thank you, Steve and Sue, for supporting the questions. And thank you to the community for participating. We will see you in 2025. Hope you can join us next month in January, on January 28th. Have a wonderful day, and we will be talking with you soon.
The USGS letters and slogan signs for a changing world appear in white in a flipping motion, then fade to black.